Algebra 2, investigating probability. This should be done after section 12.2 and before section 12.3. If you have not yet done so, you should download this from my website, this document, the Word document that is investigating probability, and give it a try. This lesson is basically the reverse of what you're probably used to, which is watch a video, do a homework assignment. We'd like you to do now is download this and really give a good attempt on this worksheet, and then come back to this video if you haven't already done that. Pause the video and then come back to this video after you've given it the old college try, and we are going to go through this worksheet together. You'll get more out of this if you would do what I just said. Of the things that we have left this year, which is I think about 4 sections of chapter 12, this is, in my opinion, by far the most interesting thing that we have left to do. So please take it seriously. And again, it's right here. I'm going to open it real quick and print it out and try your best. It's about 3.5 pages long. This video is going to be a little long. In fact, I think I'm going to do it in 2 parts. But again, remember, you don't have a homework assignment after that. So time spent should be about the same as a normal lesson. All right, and I've gone ahead and pasted these over into my starboard. It's a little bit blurry, so I apologize for that, but you've got a printed copy, and you should be able to read it off your printed copy if it's too blurry here. We'll start right from the beginning. This starts very basic. It works to the more complex. This is going to incorporate some things that you already know about probability and some things that were in section 12.2. Number 1 says the directions for 1 through 4 say that a bag contains 20 marbles, 8 are white, 10 are blue, and 2 are red. If 1 marble is pulled from the bag, what's the probability that it is white? That's a simple calculation of just 8 out of 20. If you're going to give an answer as a fraction, you should reduce that fraction. So 2/5 would be the correct answer. As a decimal, that would be 0.4. As a percent, that would be 40%. Those are acceptable answers too, unless, of course, we say what form your answer should be in. If we say answer in the form of a simple fraction, you would have to say 2/5. If we said answer as a percent, 40% would be the answer. The next one, if 1 marble is pulled from the bag, what is the probability that it's red? That would just be 2 out of 20 or 1/10. Okay, so let's get to something a little bit more meaningful. If 2 marbles are pulled from the bag with replacement, meaning that you pull a marble, you see what it is, you throw it back in, you mix them up, and you pull it again, what is the probability that both marbles are blue? Okay, so this is a compound probability where you have a calculation that is a fraction, and well, how many blues were there? There were 10, so that would be 10/20ths, or I'll just go ahead and reduce that fraction. 10/20ths is 1/2, and with compound probability, what you do is you multiply. So now we have 1/2, and we throw the marble back in, and then it's the same thing again. So really, it's just 1/2 times 1/2, which would be 1/4. This is the answer to number 3. And that is in contrast with the next question, which is if 2 marbles are pulled from the bag without replacement, meaning you pull a marble and then you see what it is, and then you set it aside. Okay, now that's going to change the number of marbles in the bag. It's also going to change the number of blue marbles that are in the bag. Okay, if you pull a blue one. So while the first calculation would still be 1/2, just like in number 3, I'm having a little trouble writing on this thing too, I think, with the pasting that I did, so please bear with me. I'm trying to write slow so it'll accept it. And then we set that marble aside. Now you don't have 20 marbles in the bag anymore, you have 19. Now you don't have 10 blue marbles in the bag if you've drawn a blue one, which is how you can continue the experiment. You have 9. So the next fraction would be 9/19ths. And your compound probability then again is multiplication, 1/2 times 9/19ths, which is 9/38. And again, if you can reduce that fraction, you should. This fraction does not reduce, so just leave it as 9/38. That's your probability. All right, the next 2 questions deal with coin flips. So, or next 4 questions, excuse me, deal with coin flips. 2 fair coins are flipped. Fair meaning that they're not weighted some certain way so that it's going to land. It's just something that comes up 50% heads and 50% tails, 50% of the time. And so it says list the possible outcomes. I've just listed them. Here's one way to represent that. HH would be heads, heads, and then heads, tails, tails, heads, tails, tails. If you flip a coin and flip another coin, or if you flip two coins that you can keep track of, one of them's got a different mark on it than the other, then these are the different possibilities. And then it simply says, what is the probability that one coin lands heads and the other one lands tails? Well, what that would be these two out of the four possibilities. And these are equally likely outcomes, right? So each one of these is 25%. This would be 50%, or the fraction 1/2. It's 2 out of 4, which reduces to 1/2. Number 7, what is the probability that both coins land tails? Well, both coins landing tails would just be this one right here. That would be 1/4. And the probability that both coins land heads would also be 1/4. Page 2. In any given situation, when all possible choices are considered, what do all probabilities have to add up to, and why? Well, hopefully you could answer this one. 1 or 100%, those are the same number, right? 100% is the decimal number 1. And that's because you can't go above 100%. There's never more than 100% probability of something happening. 100% means it's going to happen. And when we consider all possibilities, either it's this, 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 or this, if we consider all of them, they have to add up to that 100%. One of those things will happen for sure in any given situation, whether you're flipping a coin, pulling marbles, rolling a dice, whatever. I said rolling a dice. Dice is actually plural. Look at the next example. A die is singular. A die is rolled, and then a coin is flipped. And it says, draw a diagram that would represent this situation. And then in 11, it says, list the sample space for this situation. Just a couple of different ways to represent all the possible outcomes, right? You could roll a 1 and flip heads. You could roll a 1 and flip tails. 2 heads, 2 tails, 3 heads, 3 tails. And so I've kind of just represented that in 2 different ways. And these will help us answer the next questions. So looking at 12 there, what is the probability of rolling a 5 on the die and the coin landing heads? Well, rolling a 5 on the die would be 1/6, right? A normal standard die that you get in your Monopoly game or whatever, 6-sided die, would be 1/6 then. And again, with this kind of probability, like 2 things happening, it's going to be a multiplication situation. The key word here is and. The probability of rolling a 5 and the coin landing heads. And in that situation, it's actually a multiplication. The coin landing heads would be 1/2, and that product would be 1/12. There's a 1/12 chance of rolling a 5 on the die and the coin landing heads. Now, look back up to your answers in 10 and 11, and we should see that. There's only one instance where you have 5 heads. And that's this one right here. Out of 12 outcomes, there's only 1. Or if we looked here, 5 heads. So 1/12 is that answer by calculation, or if we just logically look at all possible outcomes. All right, 13. This is where it gets a little bit more interesting. What is the probability of rolling a 5 on the die or the coin landing heads? What is the probability of rolling a 5 on the die or the coin landing heads? Not and, but or. And then in parentheses, we do have or both, right? We wouldn't want to, we want to include that possibility. Okay, so one thought, the thought that usually comes up first is to say to add the probabilities, okay? So the probability of rolling a 5 in addition to, right, there's your addition, in addition to the coin landing heads, you might think to just add those 2 fractions. There's a 1/6 chance of rolling a 5. There's a 1/2 chance of flipping heads, so we'll just add them together. There is a problem with that. And the problem is that if you did that, if you just counted them up, and again, let me just use our sample space above. I'll use number 11. And if you roll a 5, that's these 2, or the coin lands heads, that's all of these. What you end up doing is counting this one twice, okay? So what we would have to do then is simply subtract that off. So the real calculation would be 1/6 plus 1/2 minus 1/12. If you don't subtract the 1/12, you counted 5 heads twice. That's 7/12. You can check my math on that if you like. 7/12 is the simplified fraction. There's a 7/12 chance of that occurring. And again, look back at the things that I circled. 1, 2, 3, 4, 5, 6, 7 out of 12. Okay, a couple more in this first video. What is the probability of the coin landing tails and either a 3 or a 4 on the die? Well, landing tails, again, keyword and. The number 12 was and, number 13 was or, number 14 we're back to and. Not to be confused with 3 or 4. Yes, we're using the word or there, but the two probabilities are coin and die, and the word is and. So that's 1/2. And then getting a 3 or a 4, that's 2/6 or 1/3. And again, we're just multiplying those, which is 1/6. The last question is kind of a dumb question. I wrote this document, and I admit it's kind of a dumb question. What is the probability of getting a 5 on the die or a 6, and also a 6 on the die? That would be 0. And your probability absolutely can be 0. Okay, so please check out the next video. I'm going to stop this one here, and then we'll finish up pages 3 and 4 on the next video.